Welcome to November 10th LeetCode Challenge. Remove all adjacent duplicates in string. You're given a string S consisting of lowercase English letters. A duplicate removal consists of choosing two adjacent and equal letters and removing them. We repeatedly make duplicate removals on S until we no longer can. Return a final string after all such duplicates removals have been made. It can be proven that the answer is unique. So we want to remove as much, remove as much duplicate removal, duplicate adjacent letters as much as we can. So for this example, say we remove BB first. I'll just write out here. A, BB, A, CA. Say we remove BB first, then we'll have A, CA. Then, what the heck? CA. Space, and then we remove AA, which will have to CA. And that's pretty much it. So we remove BB first since letters are adjacent and equal, and then the only possible move is to make, and then we have another string. Then we keep on performing that same duplicate removal procedure over, and therefore we're going to move AA from the next one because they're adjacent and they're equal, and then we'll have a CA, which are adjacent but they're not equal. Similar with this example here, it does the same thing. Remove XX first, and then remove ZZ. So the constraints are that the length of S is between 1 to 10 to the 5, and S only consists of lowercase English letters. So how do we go about solving this? So I'm thinking, since we're kind of iterating through things over, not iterating, but removing duplicates over and over the same string, it would be a good idea to use a stack. So say if we use a stack to store all the visited duplicates or characters, if a current character in the string has the same as the last character in the stack, then we pop the last character from the stack and skip the current character in the string. Otherwise, we could just append it to the character to the current stack. So let's initialize the stack first and see how we go about doing that. So we initialize an empty stack for each character in our string S. This is where we find two adjacent letters that are equal. So there's two conditions that happens. So we have to iterate through it. So if the stack exists and the character is equal to the stack's last value on the stack, then we want to pop it from the stack. So basically, don't store it, and we pop it from the last one from the stack if there are two adjacent letters that are equal. And then we gotta basically check to see if it's empty or not, and then we pop it. And then else, if it's not empty, if it is empty, then we append it to the stack. So stack dot append, and we're going to append the character. And then once we do that, all the elements are stored inside the stack. Therefore, what we need to do is return a string join, joining of the stack. And that should be it. Alright. So this has a for loop there, so it looks like it's running a big, okay, accepted, awesome. So it's running a big of n time complexity, because we just loop over essentially just S for each character in S. And space complexity is also big of n, because we store everything inside a stack of size, at most size n. For instance, if all the values are unique, then it's of n values. Or I mean, you can also look at it, yeah, exactly, that's pretty much n values. Alright, that's it. Have a great day, guys.